Hey folks, I wanted to share with you a shrunk down version, reduced version of a lecture I gave just past week in my class at Iowa State. The class I teach at Iowa State is a graduate level class titled AI Driven Innovation. And the topic we've talked about was around causal AI. In particular, we've talked about this several times in the class, each time getting a little bit more detail because I find that the causal AI is maybe the secret sauce that allows us to take advantage of this immense investment we're making in generative AI, and to overcome some of the deficiencies, traps, illusions of generative AI, by putting behind our generative AI strategies a cause and effect driven foundation. Let's be clear, generative AI is a correlation-based technology, and as such, it suffers from many of the same correlation challenges that we as humans face. And so the best way for us to address that, I believe, is to embrace a way to integrate causal AI into that generative AI ecosystem. I address this pretty heavily in my upcoming book, The AI Human Edge. It talks about how you blend these together. But I really wanted to address a question that came up in class. And I got to be honest, I probably spent 16, 20 hours of work on this presentation. You're going to get a short version of it. But I find the causal AI stuff immensely interesting, intriguing, fascinating what we can do with it. And so I'm on a mission and being led with lots of help from my friends like John Thompson, Mark Strauss, and Raymond Pettit, who are trying to coach me and educate me along this path. So I want to share with you, hopefully in 20 minutes or less, why I think this is a fundamental conversation that we need to be having in the world of AI to make certain that AI is delivering to us in a transparent, understandable manner, more relevant, more meaningful, more responsible, and more ethical outcomes. If the results we're getting from AI are not transparent and are not understandable to the average layperson, then we have failed, right? And so that's going to cause us to have a mind shift from machine learning correlation-based analytics to causation-based analytics. So let's walk through this presentation and again, try to keep it short. We've talked about why analytics struggles to tell us why what's going on, right? Without knowing why outcomes occur, our AI strategies are likely to fail. And a lot of it has to do with the fact that correlation is not causation, right? Because something happens, we don't know why it happens, and therefore, if we don't know why it happens, we can't set up for experimental design or experiential design. Statistical confidence is not the same as causal confidence and understanding why things happen and being able to identify these cause and effect relationships, interesting enough, does not start with data. It starts by identifying and bringing in the subject matter experts who can help us frame the problem we're going after so that we can use data to help to validate or improve what the domain experts know. This is different than correlation. Correlation starts with data, right? You start with data and you try to find things of interest in the data, but we know data is very backward focused, and the correlation tools don't know how to look at confounders and other sort of things that get in the way of determining causation. But what we're going to do instead is we're going to try to walk through an example of an organization who's trying to create for their patients, a fall index, right? What's the fall risk? What is the likelihood of the patient who comes into the hospital is going to suffer a fall? Because we know falls, and my talking and working with several different hospitals is a very costly from a financial and liability perspective. It's also detrimental hugely from a reputation perspective. So building a fall at risk score requires us to dive into the causal factors that drive falls so that we can not only understand why someone's likely to fall, but we can then take educated, knowledge-based actions that have a high probability of impact if we know the causes of effect, and allows us to do intervention or what ifing scenarios to figure out the best treatment plan. So the scenario we're going to do is we're going to apply a causal AI approach to try to build a patient fall propensity score. And it's going to build off of what's in chapter 5 of my book. I call it the causal AI spine, right? That it's a process that we're going to go through to make sure that not only do we build a score that's based on causal factors that we're going to put into our entity propensity models, but we're going to also have a factor in place that allows us to keep those updated not based on Bayesian or correlation-based factors, but based on causal-based factors. And so let's dive through this process. So the first step is structured causal modeling, which is to basically bring in the subject matter experts and to understand and map the variables and their relationships, right? This starts with human domain expertise. It doesn't start with data. And we're going to build this structured causal model, leveraging the subject matter experts and what they know. I ran an experiment with some students I had many years ago at Menlo College, where we went through a process of trying to identify the causal factors for predicting when someone's likely to die from COVID. Who did we talk to? We talked to nurses. We talked to doctors. We talked to people who really knew, not the random person on the street or somebody making crazy statements on social media, but you talk to the people and you start with the subject matter experts. And then we move through a process of taking what they've given us, the design process with these domain experts. We're going to test and validate and maybe enrich with data itself. We're going to challenge it with counterfactuals, and counterfactuals is a fancy way of saying what ifing. And then we're going to put in place a process to continuously learn. So again, the world's changing. We have to make sure we're building propensity scores that are also changing with the world around it. So at the end, we're going to come up with something that looks like this. This is a structured causal model created by domain experts that talk about the major factors. There's 1, 2, 6 major factors. In life, there's probably more. There's probably 12, 14, but there's not thousands, right? There's maybe thousands of factors that impact each of these particular causal factors, but themselves, things like cognitive status, how with it are they mentally, how much sedation are they on, what is their mobility status, the lighting conditions of the room they're in. And you have these sort of secondary ones like nurse response time in a fall situation is heavily impacted by nurse to patient ratio. And so you capture this and you capture some of the relationships and the strength of relationships. And by the way, I believe that I'm going to be releasing this. I believe you can build a design template to help us in a collaboration process. Think about a room full of, flip charts and post-it notes. You bring domain experts together and you're starting to brainstorm. What are the causal factors? What do they derive from? That is, how do we determine that? What are the desirable outcomes? What are the data sources, right? And understanding this, the direction and strength of relationships, right? The classic thing we do in our thinking like a data science methodology. Lots of ideation, but you bring in the domain experts, the people who really know, and you tap into that domain expert to build out a frame, the structured causal model that gives you a frame around which we're going to start building our causal AI. Now in step 2 of the first phase is when we bring in the data scientists, right? They help us translate the expert defined causal assumption to actual measurable variables, right? They go through the collection, the testing, refining, and then they're using a whole bunch of different kinds of tools and tricks and techniques. Some of these are to be honest, are kind of new to me, right? Do calculus, counterfactual simulation, structured equation modeling. These are some new tools that as a data scientist, I'm not familiar with. And so I've had to put myself on kind of a crash course with some help from my friends to understand what do these tools do and why are they so important? And they're very different than the tools I grew up with. The standard machine learning, supervised machine learning, unsupervised machine learning tools that we've used. There's a bevy of tools out there being developed. A lot of them are open source. Amazon is doing a lot of marvelous work in the do-why, pi-why frameworks, open sourcing out there. No surprise that Amazon is very big into causal AI. There's a hint there, folks, right? They're successful because they don't rely on correlations. They understand causation. And so there's a whole new set of tools and techniques that even if you're not a programmer, you should understand how these tools work to help build causal models that help to quantify cause and effect. Second step is now where the data scientist really kicks in and to build what is called this DAG, it's directed acyclic graph that allows us to actually represent the structured causal model into code, right? So we structure the structured causal model, we build the initial DAG, we run some causal tests using those tools we just talked about previously. All those different tools are helping us. We estimate the causal strengths by using SEM and do-why and pi-why. You review with domain experts, right? Domain experts aren't out of this process. They're going to be along every step of the way. We need to have human oversight as we're doing this. Domain experts who can tell us that we're heading down the wrong path or tell us about things we might be missing. You need to be involved in a continuous refinement and revalidation of the DAG process. By the way, one of my goals is to actually build a DAG design template as well, like we did for the structured causal models. That's in early stages. The early version really sucks. It's not detailed enough. By the way, these are some of the tools and techniques that you're going to use to build a DAG. So Get familiar with these. I include them here. I'm not going to read them, but this is a great starting point if you really want to learn more about causal AI and what are some of the key concepts. And eventually you end up with a DAG that has the variables around which the data science team is actually now going to build models, right? There, you've got the key causal factors, you have the mediators that are impacted by those causal factors, you have the strength of relationships, which ones are most important, which ones aren't, which by the way plays a really important part in the next stage of our analysis, which is going to be, oh, there's the DAG tool that needs work. We're going to skip by this. It just needs a lot of help. When we get into counterfactuals, and I think counterfactuals to me is the most amazing part of why you want to invest in causal AI. The ability to do what-ifing, to simulate different environments is critical, right? The ability to be able to come in here, come on screen, and figure out as well, if I use less sedatives, how does that impact the risk fall on patient A? Not in general. Not how does a reduction in sedative use impact patients? How does it impact patient A versus patient B? This is the whole concept behind entity propensity models. We're building models at the individual entity level. In this case, it happens to be a patient. It can be done for students, it can be done for teachers, doctors, wind turbines, chillers, right? We're building these things so I can make a focused, granular decision on the best treatment for that individual. In this case, the individual patient, right? This is the heart of nanoeconomics, of getting down to those individual entity predicted performance and behavioral propensities to know what I can do. And you can play with this to figure out, well, if I have to increase sedative use, should I improve the room lighting? Should I make sure there's better room staff? So now you have the ability to do that what-ifing, which is a powerful tool in AI that allows us to make very thoughtful decisions that drive material, transparent, trusted outcomes. The entity propensity models, my beating heart, be still. This is the heart. I've been talking about these since I got started playing Stratomatic baseball when I was 12 years old. The power of building these very individual entities, right? This is where we've talked about how this is where the world of nanoeconomics kicks in. So we don't treat people on average, right? We don't say on average that this is going to impact you. We're saying on average, if you're 65 years old, get a COVID shot. No, we're going to get very specific. In this case, we're going to create a fall risk score for a patient. In this case, it's Schmarzo. And Schmarzo's like, yikes, Schmarzo's not in very good shape. But now I've got a score that I can work with, and I understand from the score what are the causal factors that are impacting that, so I can do simulations to help improve his score, right? If he's got a very low mobility score, maybe I should be giving him more yoga exercises, more Pilates, more ways. If he struggled with something else, right now I can take very focused action on this entity, on this patient, because I know the factors that are impacting his fall risk. And then you got to have a continuous learning process in place, right? It goes through and it continuously learns. And we're bringing in new insights as my agility improves, for example, my mobility score may get better. Other things may improve. So we put in place a process where we're continuously looking to update these models and keep them in place. So I've also included in this presentation, which I'm almost done with, right, some things you may want to check out, some resources I used, some fabulous links you can go check out. But that's the end here, folks. I really wanted to do a very quick snapshot of a 45-minute lecture I did in class that is only the first step. As my friends who really know this better than me will tell me, it's like, Schmarzo, good start, but you got a long ways to go. I tell you what, folks, I'm up for that journey. I'm up for that challenge. And so my promise to you is I'll continue to share what I learn with other people, with you all. I'll create videos, write lots of posts, because I think this is a game changer. We've got a lot of investment in excitement and hype around AI, especially generative AI, and generative AI plays an important part in this. But without the causal, we're going to resort to making decisions based on correlations, and we know that humans do that very poorly, by the way. But if we can interject causal and understand these causal factors and quantify them and do these simulations, these counterfactual what-ifing, it puts us in control of really taking advantage and transforming AI into a tool that benefits everybody. Cheers. Thanks for listening. Let me know if you like this or not. If you do, put it in the note and maybe I'll do a few more. Cheers.